We are going to leave tonight, and we are not coming back. Not in a frightening way. Slowly and outward, past everything, until there is nothing left to pass. We will start at the moon, which is close enough to see from your window, and we will keep going, past Mars, past the asteroids, past the great storms of Jupiter, out through the rings of Saturn, into the cold blue, and then beyond the last planet into a darkness so wide that the sun becomes just another star. Space is often described as violent. Exploding stars, colliding worlds. It is occasionally over very long timescales, but mostly it is the emptiest, quietest, slowest place there is. Almost nothing happens, and then almost nothing happens again for a billion years. That is what we are traveling through tonight. Distances out there are difficult to feel, so we will use light. Light is the fastest thing there is, and it still takes time to cross the solar system. Just over a second to reach the moon. 8 minutes to us from the sun. Hours to reach the outer planets. We will be going slower than that. There is no hurry. Let's start where the sunlight is still bright, a little more than a second away. The moon is close, as these things go. Around 380,000 kilometers. You could fit every other planet in the solar system into the gap between the Earth and the moon, side by side, with room left over. That is usually offered as a fact about how big the planets are. It works just as well as a fact about how far away the moon is. The first thing that would strike you standing there is the silence, and the second is the shadows. There is no air, so there is nothing to scatter light. A shadow on the moon is not soft-edged and grey. It is black, sharp, and total. Astronauts described stepping from sunlight into shadow as stepping into something like a hole. The sky stays black even in full daylight, and the stars are up there the whole time, though bright sunlight on the surface makes them hard to see. There is no wind either, which is why the footprints are still there. 12 people have walked on the moon, and their bootprints are undisturbed, and will be for a very long time. Slowly, over millions of years, micrometeorite dust will smooth them out, but nothing will blow them away because there is nothing to blow. The dust itself is unpleasant. Lunar regolith is not like sand from a beach, worn round by water. It has been broken up by impacts and never eroded, so the grains are jagged. It clings to everything, works into seals and joints, and smells, the astronaut said, like spent gunpowder once it was brought inside and hit the air. The surface has two kinds of terrain, and you can see both from your window. The bright, rough, heavily cratered areas are the highlands. The oldest crust, more than 4 billion years old, scarred so thoroughly by impacts that new craters mostly land on old ones. The dark, smooth patches are the Maria, from the Latin for seas, named by early astronomers who thought that is what they were. They are not seas. They are enormous ancient lava plains where basalt flooded up through the crust and filled the largest impact basins, then cooled flat. The near side has a lot of them. The far side has almost none, and its crust is measurably thicker. Why the two hemispheres are so different is still being worked out. That far side is worth a moment. It is not the dark side. It gets exactly as much sunlight as the near side. But it always faces away from us. The moon is tidally locked. It turns once on its axis in exactly the time it takes to circle the Earth. So one hemisphere has been facing us for billions of years, and one has never been seen from the ground by anyone in the whole of human history until a spacecraft went round the back in 1959. For all of prehistory and all of recorded history until that moment, half of the nearest world was simply unknown. The moon is also very slowly leaving. It moves away from Earth by a few centimeters a year, taken from the energy of our tides. Which means it was closer in the past, much closer when the Earth was young, and it will be further away in the future, and eventually in the deep future, total solar eclipses will stop happening because the moon will look too small to cover the sun. We happen to be alive during the era when the sizes match. That is a coincidence, and it is temporary. The Earth hangs in the black sky over the grey plains, 4 times wider than the moon looks from here, holding still in one place because of that same locked rotation. It does not rise or set. It waits in the same patch of sky, going through its phases for anyone standing there. Outward, past the Earth's orbit, and the sunlight thins. Mars is a small, cold, dry world with a thin atmosphere, and its most consistent quality is stillness. The sky there is not blue. Fine dust suspended in the air scatters light differently, so the daytime sky is a pale butterscotch, and in a reversal that always surprises people, the sunsets are blue. As the light passes through more dust near the horizon, the blue is scattered forward around the sun, and there is a cool halo where we would expect warm colors. Rovers have photographed it, a small blue sun going down over a rust-colored plain, in near total silence. The air is thin enough that you would need a suit, and cold enough that a mild summer day at the equator might reach a comfortable temperature at noon, and then fall to well below anything on Earth by night. The pressure is less than 1/100th of ours. That thin air makes the famous dust storms less dramatic than they sound. They can cover the whole planet and dim the sunlight for weeks, which is genuinely serious for anything running on solar power. But the wind itself has little force behind it. It would tug at you gently, and it would coat everything in a fine red film that gets into every hinge. There is water on Mars, mostly frozen, in the polar caps and in ice under the surface at higher latitudes. There was once a great deal more moving on the surface. Orbiters have mapped dry river valleys, deltas, and what appear to be old lake basins with layered sediment. Something like 3 billion years ago, there were rivers there, and rain or snowmelt filling them, and then the atmosphere thinned and the water went away. The landscape kept the shapes. Mars also has the largest volcano in the solar system, Olympus Mons, so wide that if you stood on it, the slope would be gentle enough that you might not realize you were on a mountain, and a canyon system, Valles Marineris, long enough to stretch across a continent. Nothing there has moved in a very long time except the dust. Beyond Mars is the asteroid belt, and it needs to be described carefully because films get it wrong. There are millions of asteroids out there. There is also a great deal of space. The average distance between belt objects is on the order of hundreds of thousands of kilometers, often more. Spacecraft have flown straight through, repeatedly without any special avoidance. And if you were standing on one asteroid, you would probably not be able to see another one as anything but a point of light. It is not a field of rubble. It is a very sparse scattering across an enormous volume. The belt is not a destroyed planet either, despite the old story. There is not enough total mass. Everything in the belt combined is a small fraction of the Moon. The current understanding is that it is material that never managed to assemble, because Jupiter's gravity kept stirring it and prevented anything large from forming. The largest object there, Ceres, is round enough to be classed as a dwarf planet and appears to have water ice, possibly a great deal of it, beneath a dark, dusty surface. It is about a quarter the width of the Moon, and it has bright pale patches on its floor that turned out to be salt deposits left where briny water reached the surface and evaporated. A quiet, cratered, salty little world, keeping its water in the dark. Jupiter is a different kind of object, and the jump in scale is worth pausing on. It is over 11 times the width of the Earth. You could fit more than 1,000 Earths inside it. It is more than twice as massive as everything else in the solar system put together, excluding the Sun, and it has no surface. If you descended into Jupiter, you would pass through cloud layers, and the gas would get thicker and hotter and denser, and at some point, without any boundary, without any moment where you could say, "Here it is," the gas would become something more like a fluid, and then like a strange hot metallic liquid, and eventually there might be a core. You would never land. There is nothing to land on. The bands you see through a telescope are cloud belts, moving in alternating directions at enormous speeds, wrapped around the planet in stripes. Where they meet, they shear against each other and spin off storms. The largest of these is the Great Red Spot, a storm wider than the Earth, turning slowly, that has been watched continuously for well over a century and may have been seen much earlier. It has been shrinking in recent decades. It is expected to keep shrinking, though how long it lasts is not settled. Everything on Jupiter is like that. Huge, slow, and old. The moons are their own small worlds. Jupiter has dozens. 4 are large enough to see with binoculars, and they are the ones Galileo watched moving night after night, which is how it became clear that not everything went around the Earth. Io is the closest of them, and the most restless place in the solar system. Squeezed by Jupiter's gravity and pulled by the other moons, its interior is heated by that constant flexing, and it erupts constantly. Hundreds of volcanoes, some throwing plumes hundreds of kilometers up. Its surface is yellow and orange, with sulfur compounds, and is repaved so often that it has almost no impact craters. Europa is the opposite, smooth, pale and covered in ice, crossed by long reddish-brown cracks. Underneath that shell, the evidence points to a global ocean of liquid water, kept liquid by the same tidal squeezing, and possibly holding more water than all of Earth's oceans combined. That is why Europa keeps coming up in conversations about life, not because anything has been found. Nothing has, but because water, warmth, and chemistry are the ingredients, and there may be all 3 under that ice in a dark ocean nobody has ever seen. Ganymede is the largest moon in the solar system, bigger than the planet Mercury, and it has its own magnetic field, which is unique among moons. Callisto, furthest out, is one of the most heavily cratered surfaces known, an ancient, quiet, unchanged face that has been recording impacts for 4 billion years. Then Saturn. Saturn is the one that makes people stop when they see it through a telescope for the first time, because it looks unreal, like a diagram of itself. The rings are made of ice and rock, mostly water ice, in pieces ranging from dust grains to boulders. They are enormously wide, spanning a distance comparable to much of the Earth-Moon gap, and astonishingly thin. In most places, the rings are only tens of meters thick. If you scaled them to the width of a city, they would be thinner than a sheet of paper. They may also be young. Some analysis suggests the rings could be a relatively recent feature, perhaps a moon or comet torn apart within the last few 100 million years, which in solar system terms is recent, and they are slowly falling into the planet. There was a long time before Saturn had rings, and there will be a long time after. We are here while they exist. That, again, is a coincidence of timing. Saturn itself is less dense than water, which is a fact people enjoy. You could not float it in a bathtub, but the number is real. At its north pole, there is a persistent 6-sided cloud pattern, a hexagon large enough to hold several Earths, turning steadily for reasons involving the physics of rotating fluids and no reason at all involving anything mysterious. And it is quiet up there. The storms are enormous, but they are storms in thin, cold gas, hundreds of millions of kilometers away, turning at their own pace. Beyond Saturn, sunlight becomes weak. At Uranus, the sun is a very bright star rather than a disk. Noon, there is dimmer than deep twilight on Earth. From Neptune, dimmer still. Uranus is a pale, almost featureless blue-green. The color comes from methane in its atmosphere, absorbing red light. When a spacecraft flew past in 1986, it looked in the images like a smooth ball with almost nothing on it. One of the blandest views in planetary science. Its strangeness is not in the clouds. It is in the tilt. Uranus is knocked over on its side. Its axis lies nearly in the plane of its orbit. So instead of spinning upright, it rolls. That means each pole spends roughly 42 years in continuous sunlight, and then roughly 42 years in continuous darkness. A winter there lasts longer than most human careers. The likely explanation is an enormous collision early on. Something large enough to tip the whole planet over. That would have been violent. It was also more than 4 billion years ago, and everything since has been extremely calm. Neptune, further out, is a deeper blue and considerably more active than its neighbor, with the fastest winds measured anywhere in the solar system. Over 1,000 kilometers an hour in air far colder than anything on Earth. When Voyager arrived, it photographed a dark storm the size of our planet. By the time the Hubble telescope looked again, it had gone. Others have appeared since. They come and go. Neptune's largest moon, Triton, is one of the odder objects out there. It orbits backwards, the opposite direction to Neptune's rotation, which almost certainly means it did not form there. It was probably captured from the Kuiper belt, pulled in and kept. It is extremely cold, close to the coldest surface temperatures measured in the solar system, and it has geysers. Dark plumes of nitrogen erupt from its pinkish ice and drift downwind, leaving streaks across the surface. A world that cold is still doing something. Past Neptune is the Kuiper belt, a wide cold ring of icy bodies, of which Pluto is the best known. Pluto turned out to be far more interesting than anyone expected. Before 2015, it was a blurry dot. Then a spacecraft flew past and sent back a small world with mountains of water ice several kilometers high. A huge, smooth, heart-shaped plain of frozen nitrogen with no craters at all, meaning the surface is being renewed somehow. And a thin blue haze in its atmosphere. Something is still happening on Pluto. That was not the expectation for a body that far out. Its largest moon, Charon, is so big relative to Pluto that the two of them orbit a point in the space between them. They are locked face to face, each permanently showing the same side to the other, turning together like two dancers who agreed on this long ago and have not changed their minds. Out here, a year lasts 2.5 centuries. Pluto has not completed one orbit since it was discovered. There are 5 spacecraft leaving the solar system, and 2 of them are worth staying with for a moment. The Voyager probes launched in 1977, within weeks of each other, to take advantage of an alignment of the outer planets that happens roughly every 175 years. They flew past Jupiter and Saturn. One went on to Uranus and Neptune, the only visit either has ever received. They are still working. Their instruments run on the heat of decaying plutonium, which has been fading steadily for decades. Engineers have been switching off systems one at a time to keep the essential ones alive, and the spacecraft still respond. The signal that reaches Earth now is unimaginably faint, measured in a fraction of a billionth of a watt, and it takes many hours to arrive. They carry a golden record, sounds and images from Earth, greetings in dozens of languages, music, a whale song, the sound of rain, a mother and child. Nobody involved seriously expected it to be found. It was a message written mostly for the people sending it. Both have crossed the heliopause, the boundary where the sun's outward flow of particles is finally stopped by the thin gas between the stars. In that sense, they are in interstellar space. But they have not left the sun's gravity, and they will not for a long time, because there is one more region, and it is enormous. The Oort cloud is a shell of icy bodies surrounding the entire solar system, and it is thought to begin thousands of times further from the sun than the Earth is, extending outward perhaps a quarter of the way to the nearest star. It has never been directly observed. Its existence is inferred from long-period comets, the ones that fall in from every possible direction on orbits of thousands of years, suggesting a spherical reservoir far out in the dark. If it is there, it is unbelievably empty. Trillions of objects spread through a volume so vast that the average distance between them may be tens of millions of kilometers. You could stand on one and see nothing else at all. Occasionally, one gets nudged by the pull of a passing star or the slow tug of the galaxy itself and starts to fall inward. It takes a very long time. And then, perhaps 1,000,000 years later, it comes past the sun, grows a tail, is briefly visible from someone's back garden, and swings away again. Some of those comets are on their first pass. The ice on them has been in deep freeze since the solar system formed. When it warms and begins to stream away, it is the first time that material has been touched by real sunlight in 4.5 billion years. The Voyagers will take roughly 30,000 years just to cross this region. By then, nothing of them will be transmitting. They will be cold metal, drifting, still carrying their record, still moving outward at the speed they were given in the 1970s, in a place where there is nothing to slow them down. Out at the far edge of it, the sun is a star, a bright one, brighter than anything else in that sky, but a star. You would need to know where to look. Nothing out there orbits it in any way you could notice. The light takes months to arrive, and past that, in every direction, is the space between the stars, thin, cold, and very, very large. We have gone a long way tonight, past a grey world with footprints that will outlast every building on Earth, past a cold desert with blue sunsets and dry rivers, through a storm older than photography and a set of rings thinner than paper, out through the tilted blue and the backwards moon and the small heart-shaped plain with no craters on it, and further to a dark shell of ice that no one has ever seen. All of it is out there right now, turning slowly while you lie there in the dark. Nothing needs to be decided about any of it. The comets have been falling inward for 4.5 billion years, and they will get here when they get here. Whatever is unfinished can wait until morning. It is a very small thing, and the night is very large. The pictures will drift for a while. There is nothing more to listen to. Good night.